Propose an efficient transformation in the following synthesis. Mechanism not required. So the first thing we do is always count our carbons, okay, for the reactant and the product. So 1, 2, 3, 1, 2, 3, 4, 5. I didn't count the carbon coming out of the second carbon because it's the same on both sides, and my numbering verified that for me. Okay, so nothing happened to that carbon. It's still there, the methyl group is still there, so all is fine. Okay, so what I can see over here is that I am going to have a new bond between carbons 3 and 4. That's going to be a new bond form. The other thing that I have that I can see is that I have a functional group, okay, over here, and that's a ketone, all right, that I'm forming. So I have to think back about how I can form a ketone and how I can form a carbon-carbon bond. Okay, so let's look at our thinking, okay, down here. So the only way we have learned how to form a carbon-carbon bond is by taking an alkyne or alkanite ion, okay, and then treating that with any kind of an alkyl halide. And so that way you end up getting a long chain. Okay, you can add any number of carbons you want. So that's the one thing you can do. And then to get a ketone, you can use an alkyne to get a ketone. You don't need an alkene. So in the starting material here, we have an alkene. An alkene will not give us a ketone. And the other thing is that the ketone is actually not on carbon numbers 1, 2, 3. The ketone is on carbon 4 and 5. Okay, so it means that whatever fragment we are adding is the one that's going to have the ketone. So we do know how to make a ketone from an alkyne, all right? So which means that for the fragment that I have here on the left side, the alkene, I'm going to have to add alkyne, okay, to this. The first thing, that's what I have to do. The second thing that I'll have to do is I have to form a ketone. All right, so that is my strategy. But to add an alkyne, I just can't add it like that. Okay, I need to have something on the double bond that will help me add the alkyne. And looking at what I have written down here, if I'm going to add an alkyne, I need to have an alkyl halide, which means that I need to convert my alkene to an alkyl halide. Okay, so I'm going to clean up a little bit over here so we can work. Okay, and so let's do that. So which means hold on. Okay, so which means that this I have to convert to an alkyl halide, and the alkyl halide I need is going to be this, because I need the bond to form between this carbon and the alkyne. Okay, so this is what I need. Okay, over here, let me erase this arrow so it doesn't confuse us also. All right, and then from this one I'm going to add an alkyne to this, or an alkanite ion to this one. Once I have added this, I should get, and on here is where the new bond is going to form. So this is carbon number 3. Okay, and this is carbon number 1, 2, so that's 3 there. And then once I've added the alkyne, then I'm going to form the ketone. Okay, from there. So this is my steps that I need to take. So all I need to do now is actually add the reagents. I've already added the reagent for one, so I'm going to go ahead and add the other ones. So the first one that I'm looking at here is what we call an anti-Markovnikov addition, because the bromine is going to the carbon with more hydrogens. So this is an anti-Markovnikov addition. Okay, and the double bond is not there anymore. So for anti-Markovnikov addition, I can use HBr, but then I'll have to use that with light. Okay, and so HBr addition in presence of light is a free radical mechanism, and that should give us the anti-Markovnikov product. So once we have this, then you can add the alkanite ion to it. All right, how do you get the alkanite ion? This is not really available in the lab. Okay, and maybe you don't have to write this when you write the synthesis for me, but generally when you have an alkyne, the way you create the ion is by treating the alkyne with a very strong base like sodium hydride. Okay, and so that's how you get that. Now if you don't write this portion for me during this synthesis, I will understand. Okay, but I want to just tell you this is how you get it. Okay, all right, so then finally we have the last step to do, okay, where we have to convert the alkyne to a ketone. So alkyne to a ketone is going to be HgSO4 and H2SO4 as our reagent, and that will give us the ketone. And this is just a matter of memorizing your reagents and knowing what you can use, okay, where. So that is the synthesis. Involves a little bit of planning and a little bit of working backward also, okay, to what you need. So be patient with yourself and memorize your reagents.